was you put 6 over 3, right, for the scale factor? And you got 2, right? So the lengths are double. But what do we have to do to our k? Our k is our scale factor. What do we have to do to our k to compare volumes? Cube it. So we have to do k cubed, which is what? 2 cubed, which is 8. So when we're determining the volume, we have to multiply it by 8, okay? So pyramid B over pyramid A is going to be 6 over 3, which is 2. We cube it, we get 8. And we set that equal to pyramid B, the volume of B, over the volume of A. So 8 equals the volume of B, which is unknown, over the volume of A, which we know, which was 10. And how could we solve for the volume of B? Savannah? Yeah, so you would multiply the 8 and the 10, and you would get what? 80 inches cubed equals the volume of B.
I got that, but you said 20 was close.
It was close because she multiplied by the scale factor, but just remember, guys, you have to cube the scale factor, right? So for volume, we're cubing the scale factor. For area, what are we doing to the scale factor? Squaring it, okay? So for area, you're squaring. For volume, you're cubing it, right? Because volume is units cubed, right? So think about it like that. An area is units squared. Okay? All right.
No, I just did the lazy way.
Yesterday, we were like, okay, prisms, right? I want you to draw this out with me. Prisms. Oops. Had a very similar formula, right, to a pyramid, except what was the only difference, guys? The volume of a prism was base times height, right? The area of the base times the height. The volume of a pyramid was what? 1/3, the exact same formula, the base times the height. This cone, what figure that we've learned already in the past could we relate to a cone?
Pyramid.
It's very similar to a pyramid, right? But what other figure has a circular base like this? A cylinder. So draw a cylinder next to it, right? And a cylinder had the same volume equation. It was the area of the base times the height. But our base is now a circle. So it was the volume equals pi r squared times the height, right? The area of a cone, if you were to just take a guess, or excuse me, the volume of cone, if you were to just take a guess, what would you guess that the volume would be?
1/3 pi r squared height.
Very good. It's 1/3 your base times your height. And for a circle, for a cone, it's going to be 1/3 times pi r squared times the height. Okay?
Is it because you fit 3 of those inside a normal size?
Yeah, essentially you can fit 3 cones inside a cylinder with the same height. Okay? How does that work? Okay, so for pyramids and for cones, okay? When they meet at a point, always remember that as 1/3 your regular equation. Yes? Yes, you may. Okay. Now, these are just some definitions, right, of some like terms that you need to know for a cone, okay? A cone, obviously, it has that point up top. We call that the vertex, okay? The height is the same. So the height is going from the vertex all the way down to the base, okay? The slant height, that's a new one. Highlight that one, guys, okay? The slant height is not the same as the height. Someone, just by looking at this picture, what's the difference between the slant height and the height? Christian?
The height is just the height of the whole cone, and the slant height is the length of the side.
Very good. It's the length of that edge that's diagonal. Excellent, okay? And then when they talk about, also I want you to highlight lateral surface, okay? The lateral surface, imagine that this was like an ice cream cone, right? And like, you know how ice cream cones are hollow, right? The lateral surface is the surface area around the cone, not including the base, okay? It consists of all the segments that connect the vertex with the points on the edges of the base. So it's not actually including the base. It's all this area around the base, okay? All the way up here, okay? So the lateral surface is almost like if you were to stick a label on a cone, it's how much area would that label take up, okay? You can write that in there as a note for yourself. It's like the label around the cone. Your lateral surface. To find this surface area of a cone, you're going to have two regions, right? You're going to have the lateral area of the cone, which is pi r times, it's like an indexed L. It's just, that's called your slant height, okay? So circle this one and label it your slant height. Not all of them, no, okay? And your surface area of a cone is pi r squared, so that's the area of the base, plus your lateral area, okay? So this, I want you to label it, this is the area of your base, okay? So the entire surface area of the cone, right, is the area of the base plus the lateral area of the cone. And this one is your lateral area. Now, sometimes, guys, you're probably going to see like a cursive L. That's also the slant height. So please, like underneath this L, just draw like an L like that, okay? That's also how it'll appear. And that is your slant height, okay? All right, formula is going to be, we're going to have to use the slant height, and we're going to do pi r times that L, which is the slant height, which is like pi r squared plus pi rl. But we just found the area of the base and the lateral area. The volume of a cone, which we just talked about, okay? It's the exact same formula as before. It's just 1/3 the volume of a cylinder, okay? So you take 1/3, you multiply it by the area of the base and the height, okay? And that will give you the volume of a cone. Now, h in this problem is not the slant height. This is the regular height, okay? And that goes from the vertex down to the base, not along that slant, okay? So if we're looking at this cone, okay, please label, make sure you circle h, and you label an L over here and circle that one. There are two different heights. One is a slant height going along the edge, and the other one is the height straight down to the base of the cone. Thing to remember is you don't use the slant height when you're talking about the volume. You only use that slant height in the area formula. So when you're finding the surface area of the cone, okay? Remember, okay, what the base, right? Let's write that in there so you guys understand what we're looking for. This is going to be base area, okay? How would I find the area of this base? Pi r squared. Where r is what in our case? What's the r here? Christian?
5 meters.
It's 5 meters. It's our radius, okay? So it's going to be pi times 5 squared. Let's plug that in, 5 squared, and then you times it by pi. 78.5. What units do I have? Meters squared. Because what? It's area, right? Yeah, Gabby? I'll go back once I'm done with this one. Okay. Lateral area. Okay. So what we found, guys, just so we can clarify, is we found the area of this base, right? The lateral area is the area of this this portion all the way around the cone. Do you guys see the difference there? Okay. So the lateral area. Okay? So the lateral area is going to be pi r times L. We know what r is. Do we know the slant height?
Yes.
What is it? It's 8, okay? So this is our L, okay? So we're going to take pi, we're going to multiply it by the radius, which we already said was 5, and we multiply it by L, which is 8. And let's see what this gives me. It should give me like pi times 40, 125.7? 125.7 meters squared. Okay, now remember, surface area, right? It has a huge formula, right? What do I do with those two to find the actual surface area? Christian? You add them together. So surface area is the same as the base, the area of the base, plus the lateral area. So it's going to be 78.5 meters squared plus 125.7 meters squared. And that'll give me the surface area of the entire cone. So base and lateral area combined, I add those two together, and I get 204.22 meters squared. Okay, now I'm going to do this as a reference, guys, okay? Please don't copy down what I'm about to write. Copy down at the end. I'm going to calculate the volume the wrong way, and I want you guys to tell me what was wrong about it, okay? So volume for a cone is 1/3 the base times the height. And this is going to be 1/3. Our base is going to be pi r squared, so pi times 5 squared. And then my height is 8. And so I'm going to get 1/3 times pi times 25 times 8. What's wrong here? Zoe?
You use a slant height.
Very good. Very good. You guys have to understand that this 8 is not our height, okay? Our height would be this portion right here. Were we given the height for this cone? No. Do you guys think we could figure it out? How?
Triangle.
It is a triangle. It's a very special triangle that we see right now. It's a right triangle. If we know two sides of a right triangle, how could you figure out the third side? Christian? Pythagorean Theorem, baby, okay? So we'll make this our A, this will be our B, and this will be our C. Our hypotenuse is our C. So we've got 5 squared plus h squared equals 8 squared. Okay? So we're going to get 25 plus h squared equals 64. We subtract both sides by 25. We're going to get h squared equals 39. And if we take the square root of 39, (6.2) h equals 6.2. What unit should it be in? Meters. So now, do not use the slant height for your volume, okay? We're going to use the actual height, which is 6.2, from base to vertex, this one right here, which we just calculated. So we're going to get 1/3 times pi times 25 times 6.2, and that'll give us our volume, okay? So it's going to be 1/3. So pi divided by 3 times 25 times 6.2. 162.3. What units does this need? Christian? Meters cubed.
Question.
Go ahead.
Would it mess it up if you just took the base that you're calculating and added that to the height? Or wait, yeah, added that to the height.
Can you say that one more time?
Would it mess it up if you, instead of calculating the base again, you just added it to the what you get from the height times?
Oh, if you use 78.5 here? Yes, no, that would be fine. So did you guys hear what Christian asked? He asked, can we use, instead of recalculating using r squared, right, and pi, can we just use 78.5 for b? Absolutely, okay? And multiply by the height, which is 6.2. Christian, you might get a number that's a little bit off. What did you get when you calculated it? You didn't calculate it? You're going to get a number that's a little bit off. Remember, I'm pretty lenient because I don't know when you guys are going to round as to when you round. But make sure your work, that you're consistent. So if you're rounding, write down that answer so I know that you used that when you calculated it. Okay? Janas? Yes?
When finding the surface area, like what part of the thing is it?
So the surface area is like the area around the whole thing. So it's the area of the base. Like imagine you're wrapping this cone with a label. How much area?
That's the lateral area.
That is the lateral area, right? But the label, right, also is going to be over the base.
Also.
Because it's the whole thing, okay? Lateral area doesn't include the area of the base, okay?
I got 162.32, but I didn't.
Yeah, so that would round to the same thing, right?
I didn't round my answer for base. So.
Okay. All right. Yeah, let's do another one. Example 2. Yes. What's that? You were still writing down. Half of 24, which is 12. Pi r squared. So pi times 12 squared. What'd you get?
452.4.
Yep, I got the same thing. 452.4. What units is this? Meters squared, because it's area, right? What's the lateral area?
Pi r times
L, which is, it stands for what? Slant height, okay? This is the slant height, all right? So then it's going to be pi, what was our radius? 12, and our slant height here is what? 13. 490.0? Pi times 12 times 13. 490.1. It's 0.1. And then this one's also meters squared. Surface area. How do I find it? Christian? You add them together. So it's going to be B plus LA. So it's going to be 452 plus, or 452.4 plus 490.1. And that'll give us 942.5. What units? Meters squared. It's still area. And lastly, the volume. Who thinks they know how to do the volume? Mariana? Ooh, 1/3. You're going to use the B. I like that. So let's just use this B in our volume formula. So our B, which is 452.4, and then times the height, right? What's the height? Jaden?
12 squared plus
Good. And instead of b, I want to find this as h, so I'm going to change it to h. But you can leave it as b, okay? I'm going to change this to h squared. It's going to be 144 plus h squared equals 169. 169 minus 144. Take the square root. You should get h equals 5. Zoe, what's up?
Can you just assume that there's a 90-degree angle there?
Yes. You can assume that there's a 90-degree angle. Because the height, right, in order to draw a line down from the vertex to the base, part of this height, its definition, is that it has to make a perpendicular line with the base. Okay?
So it's not what do you call it? That shape if it's not like in the middle?
A cone. It's not a cone? Yes. So all cones they'll connect with the radius. Very good questions, guys. Yeah, the height has to make a perpendicular angle with the base. All right. More specifically with the radius. So now we've got 1/3 times 452.4, and then our height, which was 5. Let's see what we get. So 452.4 divided by 3, and then times 5. 754 meters cubed, because we're talking about volume. All right. How was it? It's not bad, right?
Is that it? There's 2 more steps.
2 more. The radius is going to, the same rule applies in terms of its volume being proportional by the scale factor cubed, okay? So the radius here is 3. The radius here is 9. So for us to find the scale factor, right, we're going to put the radius of A over the radius of cone B. In which case we've got 3 for the cone of A, and we've got 9 for the cone of B. We simplify this, it becomes 1 over 3. So our K value is 1/3. Our volumes are proportional by the K value cubed. So we're going to say, okay, the volume of A over the volume of B is going to be equal to K cubed. And the volume of A, we know, the volume of A is 15 pi feet cubed over the volume of B is what we're trying to find, equals our K value, which is 1/3, and we're cubing it. All right, so we've got 15 pi over, we'll just call it V for volume, equals 1 cubed, which is 1, over 3 cubed, which is 27. Cross multiply, you're going to get volume equals 15 pi times 27. Multiply all that out. Your volume is going to be 15 times 27. 405 pi. If it asks you to leave it in terms of pi, if it asks you to round it to the nearest decimal, you would get 405 multiplied by pi, and you're going to get 1,272.3. And this is volume, so it needs to be in feet cubed. Okay, just as a check when you go back, right? We had the volume of the smaller cone, and we were finding the volume of the bigger cone. Our volume should be significantly larger than the original volume that was given. 15 pi is a lot smaller than 405 pi, so that's how you can make that distinction, okay? If you got a number that was like a lot smaller, so if you got like, I don't know, what would you get here? You'd get like 3/4 or 3/5 pi or something like that, that would be wrong, okay? Because your volume shrank. We're finding a larger cone's volume, so just by looking at the image, you can tell whether your answer is roughly right or wrong. And one last example. All right, so we've got a composite solid here, okay? What are the two solids that we have here? Savannah?
A triangle. Never mind, I don't know.
Zoe?
Cone and cylinder.
Cone and cylinder, okay? So let's find the volume of this cone and the volume of this cylinder. And then we just add them together, okay? So let's start with the volume of the cone. How would I find the volume of this cone up here? Savannah?
First you have to find the base, which is pi r squared.
Okay.
And then you get 28.3. And then you get volume equals 1/3 times.
Pi r squared. Wait, how did you get, where's your radius coming from?
The cylinder.
Yes, so the radius of this cone is going to be the same radius of the cylinder. So this is also 3 meters. Very good. Or not meters, centimeters. Okay, so you did pi times 3 squared, which is 9 pi, which as a decimal was what?
28.3.
28.3. Okay, what'd you do with that?
And then I did 1/3 times 3.8.
Mm-hmm.
So 28.3 times 5. And then I got 47.2 centimeters cubed. Or 5 feet.
So then you multiplied this by pi, so 28.3, not by pi, by 5, multiplied by 5, and then you divide it by 3, 47.2? Okay, I'm with you up to there. All right, someone else take over. How do we find the volume of the cylinder? Zoe?
I have a question.
Yeah.
Why did you keep it in terms of pi? Like when you did 3, like...
You don't have to. You don't have to. I actually eventually did change it to 28.3, okay? If a question asks you to leave it in terms of pi, though, this is what you would move on with, right? 9 pi. You don't want to use the pi button in your calculator, okay? Your final answer should have a pi in it, okay? Good question. Xavier.
So to find the cylinder, you have to do pi r squared times height.
Mm-hmm.
And then so pi times 3 squared times 10. And I got 282.7.
282.7. I think that's right. Yep, I got the same thing. What units is this? All right. And how do I find the volume of the whole thing? Mariana? Very good. So volume in total equals volume of cone plus the volume of the cylinder. So this is going to be 47.2 plus 282.7. Bless you. 329.9. And this is centimeters cubed.